All right, so we're going to create a little bit of a cheat sheet today that just kind of summarizes all of the things we've learned. So the first one is we learned about perpendicular bisectors. We said that a perpendicular bisector was a line that was perpendicular to one side of the triangle and bisected or cut in half that side. This is an example of a perpendicular bisector. Please sketch that. Now, we learned that when we draw perpendicular bisectors for each of the sides of the triangle, we get what is called the circumcenter. And those circumcenters were all equidistant from the vertices of the triangle. That is, every single one of these, right, this point here, this circumcenter was the same distance from that point to the vertex, right? So this is the same as this is the same as this. Now, what was nice about this one is that it allowed us to put this triangle inside a circle. Pause the video to get the information down. This will help you tomorrow on our center of gravity task. All right, the next one. The next one we learned about was called the angle bisector. And in this case, an angle bisector was a line that took an angle and it cut it into two congruent parts. When we constructed all of the angle bisectors, we found a point of concurrency called the incenter. And we learned some cool properties about the incenter. We learned that the incenter of a triangle was equidistant from the sides of the triangle. That is, this point here was the same distance from each of the sides. Pause the video to jot this down. Then we learned what were called medians, and we learned that a median was simply a line connecting a vertex to the middle of one side of the triangle. This here is an example of a median. Unlike the perpendicular bisector, this line is not perpendicular, and it does actually cut the side in half in the same way that the perpendicular bisector did. When we draw all of the medians, the point of concurrency is called the centroid. And the property we have here for centroids was that the centroids were 2/3 of the distance from each vertex to the midpoint of the opposite side. So in this case, BR was 2/3 of BD, RD was the other 1/3. Lastly, we learned about altitudes, and we said an altitude was kind of like the height of the triangle, and it was constructed using a perpendicular line from the vertex to the base of a triangle. If we drew all of these, we got what was called the orthocenter. And the orthocenter, the lines containing the altitudes were concurrent at the orthocenter. There wasn't really any special property here. Go ahead and write all this down so that you have it for tomorrow's task. Pause the video if you need to.